My name is Kevin Kelly. I'm Associate Professor and Director of Undergraduate Teaching and Learning in the School of Engineering in Trinity College. I'd like to begin today's session by welcoming everybody, and now I'm going to talk very briefly about the E3 project in Trinity, what that is and what Trinity is, and then we'll move into a panel discussion which hopefully will help answer some of your questions. And if it doesn't, we'll have time for some questions and answers, which you're welcome to put in the chat. So you're seeing on screen there a picture of Trinity College. It's located in the center of Dublin City. It's over 400 years old, very historic, very beautiful campus, but it's also a very modern university. And E3 is in many ways the embodiment of the most modern thinking in the university, bringing together computer science, natural sciences, and engineering to think about technology and the natural world in a new way. So we think about both at the same time. So when we're trying to develop new technologies or solutions to problems in the world, that we think about our natural capital in the world around us when we do that. So that means using the resources in a more responsible way, but it also means looking at how technology can alleviate some of the challenges that we face in the world today from the perspective of sustainability. From a very practical perspective then, what E3 is a number of changes to what we do and how we do it in Trinity. One of these is that we will expand our student numbers and our staff numbers significantly in the three schools I just mentioned, that is engineering, computer science, and natural sciences. We're bringing in new programs, new buildings, new research, and all of that together is designed to produce an impact in the world around us. And part of that is a new space for learning for students, and we have a dedicated building under construction at the moment, the Martin Naughton E3 Learning Foundry. That's over 7,000 square meters dedicated to additional learning space on top of what we already have. And it's a very modern, forward-looking building designed to foster collaboration of students across all those disciplines in cutting-edge spaces, allowing students freedom to explore and work together and develop new knowledge and new technology, working with leading experts in our faculty. So that will be opening at the end of 2023. This is an artist rendering of inside in the building, and it's showing some of the public spaces, including racks of 3D printers there, some of our project space, and some of the entrance area. So having said that little bit about E3, I'd like to introduce my fellow panelists. I'll list them in the order that I'm seeing them on the screen, so there's no preference other than that. But first of all, Professor Iris Moeller from the School of Natural Sciences. Iris, I don't know if you'd like to say a couple of words about yourself. Or...
Hi, good morning and welcome everybody. It's a pleasure to be here and to see you all on this call. I'm Professor of Geography at Trinity College and also Head of Department of Geography at Trinity. So Geography at Trinity, as you'll find out if you look into the details of it, interfaces with a lot of different other disciplines. And I can tell you a little bit more about that in our panel discussion. So I'll speak to you then.
Thanks, Iris. And then Professor Jonathan Jukes.
Thanks, Kevin. Yeah, hi everyone, very welcome. My name is Jonathan Jukes. I'm the Director of Undergraduate Teaching and Learning in the School of Computer Science and Statistics. And I also like geography. Our school has lots of opportunities to study computer science and statistics alongside lots of other subjects in the university. And yeah, we're all very welcome, and it's nice to see you all.
Thank you, Jonathan. And finally, Marielle.
Thanks, Kevin. Good morning, everybody. I'm Marielle Kelly. So I'm the careers consultant here in Trinity for students in the School of Engineering and the School of Computer Science and Statistics. So my job is very much making sure that when students come in and they get all this great knowledge and learning, that they then know how to actually translate that, talk to employers and show actually here's what I've got and here's how I can help you. And also just helping people figure out where do I fit in the world with all these skills that I've developed. So I'm looking forward to talking to you today.
So we will be having a panel discussion very shortly now, but while we're on introductions, I think we might as well introduce everybody else that you're seeing on your screen here. So Zhang, do you want to introduce yourself?
Oh, hey, my name is Xia Shang, and I'm studying engineering with management, and I'm in my third year.
Thank you.
Yeah.
Cliona.
Hello, my name is Cliona McHenry. I am a first year and I am studying environmental science and engineering.
And Buse.
Hello, everyone. I'm Busa and I'm studying MSIS and I'm in my second year.
Thank you. And we have three colleagues here, I should say, from our Office of Global Relations. There's Mick Lynham, our Marketing Officer, and Melanie Mai and Nora Varga, who you'll be hearing from later as well. I see they have their cameras turned off, so perhaps we'll let them come in later. So maybe moving to the panel discussion. Jonathan, if I could start with you, one of the questions that we often get asked, I suppose, is why is technology important and how do we educate for technology or for technologists in a world that's changing very quickly?
Yeah, thanks, Kevin. So I suppose the first thing to say about why technology is important is it's very hard to think of any aspect of our lives these days that doesn't involve the application of technology in some way. So when we think about technology and computer science in particular, computer science can't exist in a bubble. It doesn't really have a purpose just to exist by itself. So computer scientists in their careers will work alongside people from lots of other disciplines to identify challenges and come up with solutions for those challenges in the real world. And as you said, technology does change very, very rapidly. And it's important though to realize that the principles that underpin an area like computer science have really actually remained the same for quite a long time. So what we do in the teaching of computer science is teach those fundamentals, but we also teach students how to teach themselves, how to be lifelong learners, because we could teach a programming language today, and as soon as students graduate, there could be a different programming language that they'll be using. So the important thing is not that they're familiar with one or two programming languages, but that they know how to pick up the next programming language that comes along. And the same thing applies to lots of other areas in technology.
Great, thanks, Jonathan. Iris, if I could come to you, I know there's an interesting new program which might strike people as a little bit unusual, which is computer science and geography. And maybe before I ask you about that program, I might just start with the geography pieces. We've heard from computer science, and I guess a lot of people know what computer science do, but maybe people might wonder really what do geographers do. They think of geography maybe as a way of finding your way from A to B, but there's so much more than that in geography. So could you tell us a little bit about the discipline of geography and what do geographers do when they're in the workplace?
Yeah, thank you, Kevin. It's one of those strange things that I think, because geography started out as a discipline of exploration before we knew what the planet looked like, and so we still associated with that finding your way from A to B kind of view, or what's the capital of this particular country. We don't do that anymore. So I think what we have built on though in geography is something that has arisen out of the age of exploration, and that's a sort of vision of the world as a very interconnected whole. So it's the interpretation of the landscape around us, the people within it, and the processes that have shaped that landscape. And so it's really about seeing that interconnectivity and also addressing the problems that are arising from that great interconnectivity, which is in a way increasing all the time. And Jonathan's just outlined the importance of technology there, and clearly, the internet has been a fabulous way by which space across the world has been drawn together and in a way being compressed, so to speak. And globalization is another aspect of that, the ability of our technology, our production of goods and so on can now span the whole world. And so geography really looks at the issues around that, how that relates to people, society, economy, political aspects of that, but also the degradation of the environment and the relationship between the physical environment and people. And we've probably all seen the news about the climate conference not so long ago, COP26, and all the issues that has raised in terms of international collaboration that's now needed to address our climate change problems. So it's our students, it's interesting because if you listen to our students, they come up with comments like, I can really now see the role that I can play within our world. I can see how the world is connected. I can see that it's not just about textbooks. You know, I can read and I can learn in the modules that we offer, but I go out, and the minute I set foot on campus, you know, some of the concepts that I have learned, and I walk around the city of Dublin, you know, the concepts that I've learned become more clear in the real world. And so it ties the natural and social environment together. And I think that's sort of what makes it unique at the moment in our sort of interconnected world. So that's how I would define it.
Great, thanks. And Jonathan, maybe flipping back to you, what's the rationale between bringing geography and computer science together as a new offering? What would you say?
Well, I might actually pick one or two examples maybe of where there's a very clear connection between geography and computer science. So a big one, I think, is the way that we use land, whether that's urban or rural settings. And it's very easy to think about applications of technology that can help us to understand that. For example, using robotic drones to automatically map land use. Anybody who thinks that agriculture in the future, you know, won't involve technology is in for a bit of a surprise. So much of what we do now has to be measured very, very carefully. You know, the use of land for different purposes. You know, they're just some examples of the way that we can use things like autonomous vehicles, artificial intelligence, data science to bring statistics into the picture as well. You know, to really get a better understanding of how we use the resources that we have available to us on the planet. The level of understanding, I think, that we need to have to be able to tackle those big environmental challenges goes way beyond what we could do without the application of technology and computer science.
Great, thanks. So I'm keeping an eye on the chat here. There's some interesting questions that come in. So there's one I'm going to flag here, which I'm going to let Iris and Jonathan think about, and I'll try and think about a little bit because it's quite a searching question, and that is, what are the main goals that the E3 project is going to achieve? Maybe while we mull that over in our subconscious, I'll take one of the other questions, which is, what kind of research opportunities are there for undergraduates, whether that be internships or working with staff members? So I think that's a really good question, really interesting, and in many ways it goes to the heart of what we would see Trinity as offering that's maybe special or somewhat different to a lot of universities. We are very much a research-driven university, and we have a philosophy of research-led teaching, which means that the professors that you are encountering in the classroom have among them some of the world's leading experts, and almost all of our staff are very active in research, which means that the two sides of the knowledge coin, if you want to use that metaphor, are development of knowledge and transmission or dissemination of the knowledge. So in the classroom, you're on the receiving end of teaching, and teaching is a very rich experience. So it's not just pushing content at you, it's actually helping you develop your own learning, and we can talk more about that later. But then there's also development of the new knowledge. So the staff that you're interacting with are not just telling you about what somebody else is finding out, they're telling you what they're finding out and what their contribution is, and also being able to look at the horizon in all of those fields. So what is coming next? So that's the first thing about a research-led university. Now, the next thing, I suppose, is how does that impact, and this goes more directly to your question, how does that impact in terms of the student involvement in the research experience? And I'll give you several examples of that. And we might come to Cliona in a minute, so just to give you fair warning there, Cliona, but we have a new program this year in environmental science and engineering, and there's a module in the first year, which is a design project. And within that module, for example, the students are talking to some of the experts in the area, in a whole range of areas around sustainability and climate and environment, and then they're working on design projects under their supervision. So they're getting exposed to some of these technologies and theories and science from the very earliest stages, literally from week one of the college experience. So I'll let Tina comment in a minute on that, but just to flag that as maybe an early taster. And there are similar examples we could pick from plenty of other programs in E3, and in many ways that will be one of the defining characteristics of E3, will be that students will be working on projects, working together with people from different disciplines and doing that all the way through their program. There are lots of other examples. Many staff members will work with students during the vacation periods, during summer, for example, will employ students or will have opportunities for students to work with their research groups. Every student must in Trinity do what's called a capstone project. So that is, depending on your degree program, between 1/3 or 50%, half of your year's work. And in that process, you work as an individual with a supervisor in the member of staff on a research-oriented project. So that's a very deep, prolonged engagement, and often you'll be working with members of that staff members' research group. So you might be working with PhD students or with postdoctoral researchers. So that's a chance to get really deeply immersed in the research. And then you specifically mentioned internships, and that is something that computer science in particular has had a long history of in Trinity, and engineering for the last 7-8 years, something like that. And again, it's something that's developing across E3. So there's a lot of opportunities there in the internships. And for those who may not be very familiar with the word, what that involves is a student going to industry, and we use industry broadly. That might be a research lab, for example, in another country, or it might be a non-profit organization, for example. And during that period, they are working in that context, developing the industry relevant skills, but they're also under supervision and producing reports and work for assessment in the university. So that's a range of some of the examples, I suppose, of things that happen. And having said that, I'd come to Cliona. Maybe Cliona, I'd come back to you. Would you like to comment on your experience in first year?
Yeah, absolutely. One, the whole thing about it being like a very research-oriented like coursework is legitimate. It is something you'll actually experience in that team design course that Professor Kelly mentioned. One of my professors, Lawrence, he tells us basically every research project he's doing. He's always is keeping us up to date because he thinks it's interesting and we think it's interesting, and because he's doing a lot of research. He works for Broad Nimona, I think, and so he does a lot of like stuff with like peat bogs and stuff like that. So he's always telling us what's going on with that because it's something we think is legitimately interesting, and it's something he thinks is interesting as well. So you will get like an in-depth knowledge of like the kind of work that your professors are doing, especially with a smaller course like mine. My course is like 24 people, so we get a lot of like hands-on, one-on-one like conversation with our professors that way. I think I've had a great like first year experience with that. I am obviously from the States. I am not Irish, and I came here, my parents are all the way across the ocean. I've like basically adrift without an anchor. And I've found that Trinity College has been really like easy for me to acclimatize to in that regard as well. Both in like educationally and like just as a place to be. I've been able to acclimatize to it really well. And I think part of that is because like the professors are just nice. And the professors like are genuinely like interested in what they are teaching, and interested in like you being excited about it too.
Thanks, Cliona. We've had a question there, Iris. Maybe I'll ask you to comment on, which is to elaborate on the Capstone project and the significance of the Capstone project for Trinity students.
Yeah, thanks. That's a good question. I mean, the Capstone project is really an opportunity for people to apply what they've learned within modules, certain skills, certain aspects of topics and theory that interested them particularly, and that they then want to explore further with respect to something that they perhaps have observed within their own life. Often students will go for something that has fascinated them about the environment in which they were brought up, or that they've encountered since then when they've been on internships or they've worked in the workplace, and they will then be supervised by a member of staff in order to to really look at a particular issue in depth and to apply the methods to that particular theory, to that particular question. So the Capstone project is really, it's a fantastic opportunity to step into the area of research and to sort of see whether that is something also that students might want to pursue later on. So I routinely see students engage on capstone projects and then come back and say, well, actually, this topic interested me so much. I really would like to do a master's within this, or I would like then to continue research and go for a PhD position. And it could be anything. I mean, we've had students who've been looking at, for example, issues around equality in housing and social housing provision. I've had students who've been looking at the future of particular coastal areas that are at threat from erosion and sea level rise, and looking at a number of different data sources. And this speaks back to the geography and computer science program as well. And there's a lot of remote sensing that's now available to us, remotely sensed data from satellites, from drones, as Jonathan mentioned earlier. And students have taken that and then worked with that and analyzed it and then come up with their own suggestion or their own theory as to what might happen next when the climate changes, the sea levels rise, and so on. And then I've also had students who've been looking at the interaction with humans again on that, and the problems that causes for society, and worked with questionnaires or with statistics on available social or economic data sets that can speak to that particular problem. So it's a great skill developer, and capstones also allow students to build transferable skills for the job market. So even those who don't go into research will gain experience in project management, they'll gain experience in data handling, data analysis, interacting with people depending on the particular type of capstone that they do. So it's great when I write students' references to know, what the capstone was that they did, and I can really highlight those transferable skills, and that enables students to enter the job market and have an advantage over others when they do so.
Thank you. So maybe I'll return to that big ambitious question we were asked about the goals that E3 has, and maybe I'll give my own first reflections on that, and then invite Jonathan and Iris to come in. I would say when you're setting goals, first of all, I think you have to be ambitious, and there's not much point in setting goals unless they're ambitious, and there has to be risk associated with them. So I'm going to put that out there, that we are going to be ambitious, and we are ambitious with our goals. And then I think you can look at shorter term goals, and I think you can look at longer term goals. And I think if we began with the longer term goals, I think the longer term goals would be that Trinity would be leading the world in terms of how technology is seen and is developed in the future, seen, deployed and developed in the future. That we think about the potential for technology to create positive impact on the world around us in a sustainable way. And we also think about how we can maybe undo or mitigate some of the effects that have been caused by human behavior and what has happened over the years, maybe before we have got as serious as we hopefully are going to get about it. So I think there are some of the long-term goals. I think the Trinity would be a leader in that. People would come to Trinity to see how do we do this, and that our graduates would go on to be leaders in industry and in research in terms of how they develop new science and how they develop new technology. I think in the short-term goals, I think it will be that our students have a qualitatively different experience in Trinity that is multidisciplinary, so that the students are seeing problems from different perspectives. So those who are coming from a science perspective will still be scientists, but they will understand the role of engineering and technology in affecting the world around us and in its potential for change. And similarly, those coming from the technology side will have a much deeper appreciation of the underlying science and of the world around us, and questions of sustainability will be at the forefront of what they do. So that's my quick framing, I suppose, of what the goals of the E3 project are. Jonathan, would you like to comment?
Yeah, I think I'd absolutely agree with that. I think from my point of view, where E3 is really interesting is when you look at, first of all, the internal connections between the different disciplines involved in E3. So the things that can happen at the boundary or the interface between computer science and the different branches of engineering, or between computer science and natural science, and between engineering and natural science. It's those interfaces where I think the really interesting work can be done, but also the external connections between what we do within the E3 disciplines and how that impacts more broadly on society. And I think we've seen a lot of discussion in relation to, for example, COP26, which Iris mentioned there a while ago, that, you know, the solutions, we can't come up with solutions that don't recognize the impact that those solutions may have on economics, for example, you know, so people's income, the amount that people have to spend and the amount that society will have to spend on the solutions that we probably need to adopt. And that's, I suppose, where students like Busa might come in with her knowledge of economics and data science and statistics through what she's studying. You know, I think one of the objectives of E3 is to make sure that the students who are developing solutions within E3 do so with knowledge and understanding of the impact that those solutions might have on wider society and on the economy.
Thank you, Jonathan. Iris, would you like to respond to that or add to that?
Well, that summarized it really well. I think it is that interdisciplinarity. I think it is also the fact that through that interdisciplinarity and the opportunities that gives us, we actually, you know, we have already seen in a way some of the impacts of E3 in that our staff have interacted directly with policy and with those who are making decisions in society, and it makes us a lot stronger in being able to do that. So you know, we are actively engaging, not just in the teaching, not just in the research, but also in advising those who are making decisions within society on how to apply it. And that's a really exciting space to be in. But you know, it's all to do with this interdisciplinary outlook that Jonathan's already outlined, and that brings us all together, and that brings the students together, and it gives the students also the opportunity to mix with one another on the modules. So, you know, people who have an emphasis on different aspects within disciplines will come together within the modules, and they will explore ideas together within our modules, and out of that emerges a lot of energy and a lot of new ideas.
Great, thank you. Maybe just to build a little on that and to address one of the other questions that's come in the chat, which is what are the facilities we provide for the learning of students in E3 or in STEM. And I suppose in responding to that question, I would say, firstly, we provide the facilities you would usually expect in a university. So we have lecture theatres, we have computer rooms, we have scientific laboratories, we have libraries, lots of libraries in Trinity. And all of those are things that you pretty much find in any university, I guess. So we have those, and we have very good facilities there. I think what will be substantially different for students in E3 is the Learning Foundry that we mentioned earlier. That's 7,000 square meters. So to put that in context, that's about, if my maths is correct here, that's about 70 times the size of a typical suburban house maybe in Ireland, of that order. So it's big, right? There's a lot of space in there. It'll be able to accommodate 12 or 1,300 students at any one time, more if people are standing or moving around. And one of the key things when we were designing that building was we engaged very deeply with the student body over a sustained period of time to see what were their reflections and what were their comments on where they felt the facilities could be improved. And we visited a lot of other universities and talked to a lot of other universities about what their thinking was. And one of the things that came back was that students wanted, and staff indeed wanted for the students, wanted more spaces where students could work together. So that's very much reflected in the design of the Learning Foundry. There are a large number of spaces, everything from small meeting rooms that 4 or 5 students can work together in, to larger project spaces, to what are called maker spaces, where students actually have access to equipment and materials under what I would call light supervision. So that is, they have a lot of control over what they do. They don't have to, you know, go through kind of complicated processes to ask for things to be made. They can get training, and then they learn how to use the materials and resources there to do things themselves. And flexibility has been another key, I suppose, in terms of how that space has been designed, so that every space has been designed to be used in a number of different possible configurations. So there are a couple of the things I think that are maybe a little bit unique or distinctive about the learning experience within E3. I'd like to bring you in now, Marielle. There's been a couple of questions about the kind of jobs that might be available to people coming through E3. We've had computer science mentioned, we've had environmental science and engineering, we've had computer science and geography all mentioned. And more generally, I suppose, what is the job outlook like in Ireland, and what does Trinity do as an institution to help people in that transition from the university to the working world?
Great, thanks, Kevin. So I'll just take up the rest of the webinar with the jobs from all those different disciplines. I mean, really, there's so many opportunities. Our students are so employable. Like we're in the top 50 globally in terms of the employment rate of our graduates. So there's no kind of question around, are our students employable in whatever discipline they go into. And I think, certainly, there's resources that we have on our website in terms of the different job titles you can go into from all these different courses. But I always encourage people to kind of move away from job titles, because they change so much, year on year, company by company. It's not the most useful way to think about, what am I going to do? What course will I do? Where will I go? The useful way to do is kind of think of, what do I want to do? What do I want to contribute? There's so many big problems in the world that are being addressed by the kind of areas, we're researching here in E3. What is the problem, or the kind of, cluster of problems that you find the most fascinating, the most engaging, the most urgent? And then within that, what part of fixing that do you want to be? So do you want to be, advising the policymakers, as Iris was saying? Do you want to be, gathering and analyzing data to help people come up with solutions? Like, what is your skill set? What is the stuff that you really enjoy doing? And how then will you take a course that's going to give you the equipment to go forth and do that? And I think what's quite, interesting about this whole kind of E3 concept is it's taking stuff that we've always done really well. Like, our students are, you've heard from Cleena, you'll hear from the other two, our students are fantastic. They come out with a fantastic education. They're bright, they're engaged. But more than that, they have all these skills, and this Capstone project is fantastic, because what you get is this really practical application of your knowledge, but also, as Iris was saying, these really transferable skills. So you look at, like, what are the skills we need in the workplace today? It is, critical thinking, complex problem solving, dealing with different people when there's conflict, all these kind of really soft skills that are massively important. So students come out not only with a really strong knowledge base, but also very, very transferable skills. But then what the E3 thing does that's quite exciting, I suppose, is, our job is to help students identify what they've got and explain that to employers. And E3 just gives them an extra string to their bow than what they already had. Because now not only do you have this knowledge and these skills, but you've got this literacy across different disciplines. So when you're standing in front of an employer, you're not just in your silo. You don't just know this one thing. You've got all this other knowledge to draw on. So from a careers perspective, it makes my job even easier, because I'm like, well, here's this other amazing pillar that you're kind of bringing across. In terms of how we support that, there's lots of different things that we do. So on a very practical level, we have scholarships to help support students to enhance their employability. We have employability awards, which is where students engage with employers and go to their workplace and learn their skills. We do very practical stuff around, getting your CV right, getting your interview skills right, all that kind of stuff. So anything students need in terms of getting to a role, we will help them. And that's for casual work, it's for summer internships, which lots of our students would do in industry, and it's also for graduate work. So there's lots of different supports there at any point when they get into Trinity to help with that transition.
Thanks, Marielle. I think at this stage we should perhaps hear a little bit more maybe from the student side, and we've definitely had a few questions about the experience. So Cleena has given us a very eloquent exposition of her experience, at least in part, in first year. So I'd like to bring in Shang and Busa now, and maybe the things I'd like you to comment on a little bit would be, what is your experience as an international student coming to Trinity been like? And that can be within the classroom in terms of teaching and learning that you've enjoyed, or it can be the broader experience either of living in Dublin or Ireland, or the Trinity specific experience. So feel free to bring in clubs and societies, for example, or extracurricular activities that you're involved in. And obviously we have to acknowledge probably a significant part of that experience also has been within COVID, so we'll factor that in, but we can comment maybe more specifically on that later. So Busa, would you like to come in there and say anything on that?
Yeah, so my course is Management Science and Information System Studies. It's such a hard course to explain because you get all of economics, statistics, management science, business, and everything you can think of. I'm in my second year right now, and as an international student, I'm the only international student in the course right now, which is such a different experience for me. All of my course mates are from Ireland, which I'm getting on really well. They're so welcoming, plus Dublin. And like, it was my first time in Dublin, also in Ireland last year as a first year. And I was so scared to come in without my family, without my friends, without my country. But both Ireland and Irish people are so welcoming here. It made me feel like home. Of course, there are some hardships that comes around being an international student, but I think it's worth to have because you get to live a different experience than people who are already living there. You're by yourself on your own, handling everything by yourself. But I think it makes you an independent person. And I think it gives you a lot of different perspectives than other people. I think like it will give, and I think it will also help me with my like future problems in the real business world as well.
Thanks, Busa. And Shang, would you like to come in?
Yeah, I also is doing engineering with management is also a small course, and most of the people also from Ireland. So luckily I get quite along with them, and then they showing me around the city. They show me, they tell me history of the country, and then they never stop amaze me with how much they can drink. And then with the societies, Trinity honestly offers all kinds of societies you can think of. And then I'm more like a sports person, so I joined American Football and Football Society at the start of the year. And then if you are pretty good at some specific sport, then there's always a college thing for you, with more sales training, more games, and with public coaches. So as myself, currently I'm playing for Trinity basketball team, and we have training twice a week, and then every Monday we have a basketball game. So if you're interested, not just sports, there's music, there's anything you can think of, there's a society there waiting for you to join. So I really like that a lot.
Great, thanks. So I've had a couple of questions about engineering, and I guess it probably falls to me maybe to answer some of those. One of them is what's a typical day like for an engineering student, and I think Shang will probably nod his head when I say it's busy. The nature of the engineering education is that it's quite structured. So in a typical day, you'll probably have 4 to 5 hours of tuition on average, plus another couple of hours where you might be doing labs, or you might be working with teammates on a group project. I've also been asked about how the engineering degree at Trinity is structured, and my answer to this is always it's not quite as straightforward as it may seem at first, and it may not even seem straightforward. So if somebody says to me they're interested in doing engineering at Trinity, I would say there's 4 options, or perhaps even 5 options you should consider, depending really what you want to do. And where people tend to start is what we call the general engineering program. So that's our largest engineering program. That has the feature that we do 2 common years, after which you can choose to specialize in a number of different disciplines. So that is civil engineering, which includes environmental and structural engineering, electronic engineering, computer engineering, computer and electronic engineering, mechanical and manufacturing engineering, and biomedical engineering. Hopefully I haven't forgotten anybody there. So that's one program we offer. We have the engineering with management program, which Zhang is in. That's a little bit more specialized. It's very broad, but broad in a different way. So it's broad by having more business and management content with a very strong focus on design, and really centered around mechanical manufacturing and biomedical engineering. We have the environmental science and engineering program that CLEAN is involved in. So that allows you to have a tighter specialization around environmental science and engineering, as you'd expect from the title. And you can orient yourself later in the program more towards a scientific orientation or more towards an engineering orientation. So that's 3 programs, I would say, but other things you could consider are, if you're very interested in being in the area of, say, computer engineering, then you should be looking at the computer science program as well. And I'm going to come to Jonathan in a minute, maybe, to talk about the difference between computer science and engineering. And in many ways, the MSIS program, the Management Science and Information System Studies, in fact, I believe at one point in its early years, it may even have been called industrial engineering. So there's a lot of overlap between the MSIS program and, for example, the engineering with management program, where students share modules. So they're the kind of options you should probably consider, I suppose, if you're thinking about doing engineering. And having said that, Jonathan, maybe I can bounce back to you to comment on the differences between computer science and computer engineering.
Sure, thanks, Kevin. I suppose one of the first differences, just to restate something that you said, is in the case of computer engineering, at Trinity, you'd be studying that by studying common or general engineering for 2 years and then specializing in computer engineering, or indeed electronic and computer engineering at that point. Whereas if you are entering our computer science program, you're going to be studying principally computer science for the full either 4 or 5 years of the program. And that's the student's choice to study for either 4 years to honours bachelor's level, or to study for 5 years to master's level. There's some slight differences in terms of focus, emphasis, breadth and depth, as you would expect. So in computer science, you'll tend to see a little bit more statistics and data science, and you'll tend to see a little bit more software engineering and more emphasis in areas like artificial intelligence. Whereas in computer engineering, you'll see emphasis on electronics and hardware, what we call computer architecture, and you'll see emphasis on telecommunications. But also when you're following the computer engineering pathway, going into your 3rd year, you have the option to combine computer engineering, if you want, with electronic engineering, which opens up lots of other areas as well, particularly, I suppose, the more electronic side of telecommunications. So when you look at career pathways coming out, Marielle will probably have seen this with our graduates over the years. What we tend to find is graduates that fall into different categories. First of all, a lot of the graduates coming out of computer science and computer engineering can often end up following very similar career paths at that point. So the 2 different routes are not necessarily limiting in terms of career pathways. But then I suppose the computer engineers, some of them may tend to drift more towards the hardware, telecommunications, also graphics and vision, those sorts of areas, whereas the computer scientists may tend to drift more towards the software engineering area. But there is a lot of overlap as well.
Thanks, Jonathan. We'll need to bring this to a close reasonably soon, I guess, this part of the session, but I'd like to address maybe some of the topics together that have come in. So I'll just read out a couple of the questions, and I'll try and give an answer to those. So one of the questions relates to innovation and entrepreneurship. A second question relates to the opportunity to study content outside your core program. And a third is asking whether we have any engagement with NGOs, non-governmental organizations. So to try and look at them together, and that's not easy to do, I would say, firstly, looking at the studying outside your own course, that is very much a key principle of a Trinity education, and every student has the option to study at least 2 modules during their undergraduate program, which are selected by themselves with no restrictions. So there's a list of, I think, 42 modules currently on offer that students can study from any discipline. and nobody can tell them what to study or what not to study within that list. So that's really an opportunity to explore completely freely. And then on top of that, there is a wide amount of choice within the individual programs. The boundaries between the individual fields are much less rigid than they maybe would be, and that's very much a feature of E3. So the opportunity to study and work and learn across disciplines and across other fields is definitely there. With regard to innovation and entrepreneurship, then part of that offering of those study programs include modules in innovation and entrepreneurship, some of which you can actually get a separate certificate from, which is maybe nice if you want to have something that you can put on your CV. And then more generally on the topic of innovation and entrepreneurship, first of all, to note that Trinity is very highly regarded internationally for its innovation and entrepreneurship, particularly on the student side, but also on the staff side. So we're the #1 university in Europe and have been for the last 7 years. Since those rankings were started by a company called PitchBook, which is a company that tracks investment in startups. And we're the #1 university in Europe for revenue raised by student-generated startups. So we have a whole area within the university called Tangent, which exists to help, among other things, help students commercialize ideas. And we have, in engineering and computer science in particular, we have a large number of spin-outs come from there, both from the staff side and from the student side. And finally, in terms of working with NGOs, there's a lot of really good examples, and a lot of those, in fact, overlap with the startup area. We have a lot of our students are very active in what we would call social innovation. So that is applying innovation and the startup mentality and process, but applying it to producing social impact, not just financial impact. So many of the academics will work and will bring into the classroom their work with non-governmental organizations, whether that's organizations like Médecins Sans Frontières, or whether it's Engineers Without Borders would be one that would cross my path sometimes, or with various organizations working with disaster relief, working with poverty, working with social exclusion, working in a whole range of areas. So there are a number of startups I could mention, such as Food Cloud, such as Flow Waste, such as Akara Robotics. These are startups I'd be familiar with that have come out of student activities within the university. So with that, I think we're probably coming towards the end of this session, and I would like, I suppose, to hand over to, well, thank you all for your questions, and we may have time to address one or two right at the end if we can, but I do need to keep some time here for Melanie and for Nora and Mick, who are going to tell us a little bit about the opportunity for some scholarships.
Thank you very much, Kevin. Let me just share the slide. Thank you, Kevin, and it was a fantastic, great information from the panel today. So just very quickly, I would like to recap who we are and what we do. As you have heard from today's session, there are 3 participating schools in the E3 project: the School of Computer Science and Statistics, the School of Engineering, and the School of Natural Sciences. So on the slide, you can see all the undergraduate programs that are offered by the 3 schools. The slides and the recording will be shared with audience today afterwards. So don't be worrying, because we don't have the time to go through all the programs in details, but the recording will be shared with you. One program to note that is not listed there is the International Foundation Program, which is for students who are interested to join Trinity to do the degree programs, however, may need additional academic support and may not quite meeting the entry requirements for the degree programs. Just bear that in mind. So very quickly, just to go through the application portal is now open and will close on the 30th of June. Bear in mind that some of our programs tend to be extremely popular and they can be oversubscribed, and as a result, that the application may close earlier than the deadline. So if you are considering submitting an application, please do bear that in mind. The application process is very simple. Go onto the link on the slide, and then to complete the online application with your academic documents, also to upload your personal statement with 2 references. There is an application fee of €55. Students are allowed to submit up to 3 applications. So this is a bit of information that I would like to focus on the scholarships. At Trinity, we would love to, I suppose, encourage and support excellent students. So there are a number of scholarship opportunities available for our students. So there is the Global Excellence Scholarship, one time up to €5,000. We also, through the E3 project, there are a good number of E3 scholarships for all E3 offer holders, value between €2,000 to €16,000. And also we offer the very prestigious Trinity Foundation Scholarship, which is for a duration of 5 years, highly prestigious, and it's awarded on the basis of elective exams at the 2nd year. And also it confers a lifelong status in the college. So for detailed information on all the scholarships, that you can click onto the link on the slide. So you will get information on the application process, the deadlines, and the and when the announcement will be made. So please visit the link there if you're interested. COVID is still very much part of our lives. So for those of you who are interested in finding out how Trinity is handling the health and safety measures, what we do to protect our staffs and students, this is the link here that for up-to-date information if you're interested. So at last, that I would like to say thank you on behalf of the E3 team. If you wish to speak with the E3 team, my colleague Nora and myself would be delighted to meet you virtually to provide you with more detailed information on the program offerings, admissions, and available services. So here's the link if you wish to schedule an appointment with us. This is the contact email address and the E3 website. For more information, we do have further questions that we can't take today, so you're more than welcome to get in touch and we'll try to provide the information when required. So thank you again. This session is recorded and will be shared with you. Now I'm going to hand you back to Kevin.
Thanks, Melanie. So we've actually managed to finish a little bit ahead of time, which is nice. So given that we have a few more minutes, I might just try and take a couple of questions, and feel free to type any more in there, and we'll try and get to them. So I'm scrolling through the list here of things that have been put in the chat, and trying to see are there any we could maybe address in the last couple of minutes. Yeah, so one maybe for Shang here is, are there extracurricular engineering related activities that you can do? And if you're not aware of some, I can certainly answer there as well. And then a related question, which we'll open up, I guess, to everybody else, is about what aspects of your course, are there any particular experiences you've had in your classroom or in your learning to date that you particularly enjoyed? So Shang, if you're not aware, then that's fine, but if you do know of any, then feel free to comment on that. And then more generally on the second question, which was any particular aspects of your learning you've really enjoyed to date.
So there's 2 that I know of. One is just Engineer Society, but I haven't really signed up for that one, so I don't really know what kind of events they have. The other one it's called Trinity Formula. Basically, you have, I think you mostly work on CAD, and then you try to design your own car. And by the end of the year, you can race the car against other companies and college. I think it's really nice because anyone that designed a car that have a license are able to drive this car. And if you have the fastest time, if you get the fastest time for your track, then you're going to be the driver for the team.
Great, thanks, Zhang. And any aspects of your learning that you've particularly enjoyed in your time in Trinity?
Sure. Like in my first year, there was a course, a module called material engineering. We did a lot of interesting labs. For example, like constructing a bridge with wood and steel wire, and then see which group has the which group's project can like take the greatest load. And then we also had a few sessions to work with concrete. By learning how to mix concrete with steel bars, you minimize the weakness in tension. In my second year, I heard a lot of good things from the past students, how they manufacture guitars, stuff like that. But unfortunately, due to COVID, that didn't happen to us. But we did work on SolidWorks, which was quite an experience for me. So yeah.
Thanks, Zhang. And Cliona, would you like to come in and talk about any aspects of your experience that you haven't mentioned already?
I didn't talk much about societies. I greatly enjoyed doing society things. I'm personally part of knitting society because I'm secretly an old grandmother at heart. I found that the societies, like the breadth of the societies, is super like valuable to like students, because whatever you're interested in, someone else is, and someone else has already like done that and like made a society for it. So if you're like me, interested in knitting and crochet and whatever, and you can just go and be like, you can just go and sign up for the society and go to their events, and it's fun, it's good, you make friends that way. Because especially with larger courses like all the engineering courses, it's hard to make friends because there's like 200 or 300 people in a lecture hall. So if you find you're struggling to make friends, I would totally recommend like finding the society that fits you and make some friends there, because you'll definitely make friends there.
Also, can I just add one more thing?
Sure.
There's always it has nothing to do with engineering, but if you're looking for friends, there's always different international societies. For example, Chinese society, Asian society, whatever you're interested in. Whether you want to meet some French people, you can join their society. So there's always opportunities for you to meet new people, which is great.
Thanks, Zhang. And maybe Busa will give the last word to you.
Yeah, in terms of societies and clubs, I'm also in part of like tennis and snow sports in terms of like sports. And like we have trainings every week as well, and also tournaments in the next semester. What Zhang and Cliona said, like it's such a great way to make friends, because they organize a lot of things like pop clubs every week, or other events. So it's such a good way to make friends. And I'm also part of DAMSIS, which is an organization of MSIS as well. As we were like not so many people, we can organize trips to Europe as well. So yeah, that's what I can say.
Great. Well, with that, I think I'll bring this session to a close. I'd like to thank our three students, especially for being here today and for speaking so well on behalf of the student body and the student experience. To my colleagues across the university for their contributions to the panel discussion. And last but not least, to everybody attending, thank you for your interest, and thank you for all the questions, and goodbye.